Our next outstanding alumnus, Craig Niederberger, class of '82, is professor and head of the Department of Urology at the University of Illinois at Chicago. He has many impressive things to talk about with fertility and sterility. And just a word that I've been asked to pass along, some of his slides may not be for the squeamish. So if you are squeamish or are in the company of somebody who is, you may want to skip this talk. If not, for Professor Niederberger.
So thank you to the college and the Board of Governors and the selection committee for this really meaningful honor. I am a mutter, so there is a not so little voice in the back of my head saying, everybody else is so much smarter. Why on earth did I get this? So thank you. I want to begin by saying that I've had so many incredible faculty when I was at MUD. And so to call out one doesn't mean that I'm saying that there weren't so many that were incredible. But I'm calling out J. Arthur Campbell because he was such a remarkable professor and teacher and really sort of like put a seed in my head that developed into the career that I have today. And that was a comment that he made, which was, why Harvey Mudd is so great is that you can go from anything to anything in your life, which is true. I mean, this weekend has been full of examples of that. So I'm a surgeon. I do microsurgery. I see patients. I have been a molecular biologist studying the development of the sperm cell, spermatogenesis. But in my 40s, I found my true passion, which is bioengineering in medical device innovation. So I'm going to tell you a little bit about that. So essentially, what I do can be considered the surgical user interface, an interface which has not changed for about 2,000 years. There have been some minor changes, but the essential interface is pretty much the same. So it's a huge space. Surgery is a huge space for innovation, or to put it another way, what we do today is barbaric. For example, we all know the sewing machine exists, right? It was invented in the mid-19th century. We still use needle and thread for the majority of surgery that we do. How crazy is that? I mean, think about it. You know, everything that we're wearing in this room today was made by a sewing machine, right? So why on earth are surgeons still using needle and thread? It makes absolutely no sense. So this, for example, is a investigation into a haptic device with a 3D imaging system that we're looking at to train surgeons how to put needles into the right place in the body. In fact, this master's student will be defending his thesis tomorrow. But the example that I wanted to give is one that we've taken fairly far, and that is, how do you solve the problem of urinary incontinence, which is a huge problem. About 50% of women and about 10% of men will experience stress urinary incontinence, which is just kind of the resistance of the bladder failing, and so urine leaks out over the course of their lifetime. 10% of all women will undergo a surgical procedure for this. So this is a big area of medical need. The problem is that the current method that we use to solve this problem is to increase the resistance of the urethra, the outlet of the bladder. And we do that using typically a synthetic sling. So you put in the sling, you sort of like impart enough force, and then you've solved the problem. But you can make a mistake in two directions. One is you don't impart enough force, and so the patient continues to leak. Or you impart too much force, and the patient goes into urinary retention. In other words, they can't pee at all. And unfortunately, both sides are fairly high prevalence. So how do we do this? How do we fix that problem? And it's a problem, in fact, that is shared not just in urology, but the problem of putting force on tissue, for example, in neurosurgery, brain tissue or neural tissue, which can kill it, or in putting in prosthetic devices. This is a problem that is medicine-wide. And the problem is that we are really good with our hands for a variety of sensory and motor applications. But what we aren't good with our hands at is figuring out force. So if I asked you how much force was being put on your hand to 2 significant digits in newtons, you wouldn't be able to do it. Likewise, if I said, okay, put 4.2 newtons of force on an object, you wouldn't be able to do it. That's just our limitation. And in fact, with the sling device, right now it's just sort of guesswork. It's like, yeah, I think that I'm putting enough force to stop the urinary leak. And that's why there's such high prevalence in the complication rate of not solving the problem or urinary retention in both directions. So we devised a very simple solution to this, and that is measure the force that it takes to stop the leak and then recreate the force in surgery. So this is a very, very rapid prototype that we tested in animals, and it worked. So then we went and tested another very, very rapid prototype in humans, and it worked. We actually put this thing on a glove so that you could feel the force with your finger, and it worked. And so we started to ideate around designs. And so this was one of our first designs, having the sensor and a box be separate. But we really like that concept of a glove. You know, it's such an intuitive concept, right? And that is that, you know, the surgeon just applies force or measures force and can see it directly on a readout on the glove. So this is a lesson that I learned at Harvey Mudd, and that is, even though you are the user of technology, you're not necessarily the one that can figure it out. You still need to do user studies. So I'm a surgeon. My co-faculty are surgeons. We all thought that the surgical glove was the coolest way to innovate around this. And so we took it into the clinic, and we found that our colleagues, our urologic colleagues, were actually taking the glove off, putting a tongue depressor in the glove so that they could angulate it to get the force measurement. The urethra at that point is kind of difficult to feel, and we as users knew how the technology worked. We could do it, but naive users found it much easier to use this sort of paddle in order to make the force measurement. So this is the device that we're taking to FDA. It consists of two different models. One model is to measure in the clinic the force required to stop the urinary leak, and the other is the one that you use in surgery to measure the amount of force that the sling then is required to put on the urethra. So how does this look? How does this get to where it is? So this is my role inside of the university. So I'm part of a lab, and this is my lab. And what does this lab look like? Well, first of all, it's a highly multidisciplinary lab. So we have engineers. I'm both in the College of Engineering as well as the College of Medicine. We have physicians and physician trainees, and we have designers. So we have a variety of different kinds of faculty and learners in our lab. And at a variety of different levels in education and in teaching. So we have medical students, we have residents, we have fellows, we have undergraduate engineers, we have graduate engineers, we have faculty in design, we have faculty in engineering, we have faculty in medicine, and they're all sitting at the table together. In fact, we even have physicians that come in from the outside that bring their problems to us to solve. So this is kind of what our technology stack looks like. So the Uro Lab is my lab. It lives inside of the UIC Innovation Center, which is a center which includes the College of Medicine, the College of Architecture, Art and Design, the College of Engineering, the College of Business, a wide variety of colleges bringing learners and faculty together. And NexHand is the company that we founded to commercialize the IP, because as you would expect, we create a tremendous amount of IP inside of the university, but it's not very useful until there's a way to make it real. And so NexHand is designed to do that. So for those who are students, who are tinkers, who are tinkering in high school, outside of the classroom, and you know, Harvey Mudd is a very immersive environment, a pressure cooker environment, but I pretty much knew that there were a number of students, if not most, that just had so much creativity that bubbled over that they were still doing really, really incredible things outside of the classroom. I think that's just really important, and it's an important part of life to have outside of the institution, creativity as well. So this is functionally our garage, our kitchen table. So that's my older daughter, who at the time was attending the Rhode Island School of Design, helping us with the design, my co-faculty, urology, and his wife, who's an artist, and this is our trying to figure out the design of the device. But I'm a teacher, and it's probably the most gratifying part of my job. And the group of people that I have to say I just enjoy working the most with are undergraduates. So this is an undergraduate engineering project. This is one of my undergraduate engineering teams. As I'm sure you know, pretty much the entire world's engineering programs inherited from the clinic program here at Harvey Mudd. So this is what we call the senior design project. And the ones that come to urology tend to do quite well. We have an expo every year with about 100 of these teams, and urology wins the competition, the entire competition, not infrequently. And that's because these are functionally the offspring of Harvey Mudd. So I want to end with this concept, and the concept is really sort of like, how do you get to medical device innovation? And historically, and by historically, I mean all the way through the last century, it's been a system. And the system is that the physician comes with a scrawled idea on a napkin to the engineer and says, can you make this work? And the engineer says, sure, give me $1.5 million and I'll start to work on it. The other way that this works, and we see this a lot in the university, is that engineers are doing this incredibly cool bench research. And they come to the solution to an engineering problem that they think has medical applicability. And so they shop it around to, say, to an anesthesiologist, and the anesthesiologist, I don't think so. To a radiologist, I don't think so. To a surgeon, I don't think so. To a psychiatrist, I don't think so. To someone in renal medicine, I know how to use that piece of technology to solve my problem. So both of these models were responsible for tremendous innovations up until the last pretty much century. But we're finally beginning to experiment with better ways to do this. And one way that a number of centers in the United States and Europe and elsewhere are really sort of beginning to think through is to have engineers kind of like do user studies around physicians. So follow around physicians, help physicians do problem identification, and then specification and solution. And that's wonderful. But the bleeding edge, what we're innovating, is to bring everybody together, to bring students and faculty in engineering, medicine, design, business together into one place. Everybody is working together. Sounds familiar? This inherits from Harvey Mudd concepts. And so this is what we're working on now. And in fact, if you're a student, we have a program in the College of Medicine called IMED, which takes 12 students a year and teaches innovation in medicine. So Mudders would be perfect for this program. So if you're a student and you're interested in a career like this, please reach out to me. And if you're faculty that are advising students and you think that some students may be interested in this, please reach out to me, because what we really need is we need a pipeline from Harvey Mudd College. So I have to say the best thing, though, that happened to me when I was at Harvey Mudd College is that I met the most incredible person in the world, and that's my wife, who was a student who was starting Scripps when I was ending Harvey Mudd College. We have two amazing daughters that they wouldn't exist on the planet if it weren't for the geolocalization of Harvey Mudd and Scripps. So it's really kind of the most incredible thing to me. So I just wanted to thank you for this really, really meaningful honor and an undeserved one, but thank you very much.